So we're going to look at determine whether a point lies on the line or not. I think we did that before, or maybe not. Okay, so to check whether the point lies on the line is to substitute. So we go to the left-hand side of the equation, replace the x value by 5, replace the y value by 6, plus 20. Now work this out on a calculator. All right, so you should get 0, right? So if you subtract this, you get 0, which is the right side. Does that make that equation true? Yes, so you can conclude that this point lies on the line. Try the next one. See if the next point lies on the line. So that means that line passes through this point. Try the next one. See, this page is like less than a minute. So it doesn't really count. So easy. All right, let's go. Left-hand side is y, 4. Okay? Right-hand side. So this one's a bit different. You got pronomen on both sides, so you have to substitute onto both. Does that make sense? Are they equal? Not equal. So what can we say? Yeah, or do you say the line does not pass through the point? So you can say the line does not, the line does not pass through 1, 4. Yes. Negative 1, 4, yeah. Okay, thank you. All right, so make sure you know how to check things. There you go. We'll move on very soon to distance. Get ready. All right. All done? It didn't take that long. I'll tell you what I do. Okay. All right, thank you. All right, next page. What time I wake up? Now we're going to look at distance between 2 points. The distance between 2-point formula, I think is on the reference sheet. So have a look. Is it on the reference sheet? Yeah, it is on the reference sheet. So, but it will be good to remember it so you know how to use it. So this is on the reference. On reference. Now let's see where this formula comes from. Okay, this formula comes from 2 points on the number plane. So we got the points A, and we get the point B. And when we join them together, we want to find how long is AB. So what we do is we use Pythagoras theorem, and you can find that these two, this is y2, y1. So the gap between them is y2 minus y1, and the gap between the horizontal length is x2 minus x1. So what does that tell you? That if you use Pythagoras, AB square is equal to this square minus this square. Okay? And then you square root. Okay, that's the formula. You need to know how to prove it now, but that helps you to understand where it comes from. It's more likely you will remember. It is a result of Pythagoras theorem. This is the distance formula. Okay, so we can use this formula to do examples. Let's do some examples. Okay, write it down. Okay, good. Right, hopefully you're done. Shouldn't take that long. Okay. Right, okay, let's move on. So, still recording, that's good. Okay. Let's find, using the distance formula, to find the exact length of AB given these 2 points. So using the formula, that's your x1, y1, x2, y2. You go AB equal to the square root 5 minus -4 square plus -1 minus 2 square. Okay? This is your x2, x1, y2, y1. Okay? Now let's work out, because you want the exact form, you have to do it on your you can do it on a calculator. Let's get your calculator. So you go bracket 5 plus 4 square plus -1 minus 2 close bracket square equal 90. So you go square root of 90. Remember exact length. So what you do is square root of 90. You can simplify square root of 90. How do you simplify? Yes, because 9 times 10 is 3 root 10. So we say this in leaving your answer in third form, or in other words, it's called the exact form. Okay? Right, that's what you do there. Then after that, you need to be able to work out in 2 decimal places as well. So AB can also be simplified to 2 decimal places. So you write square root of 90 equal 9.49, right? 9.49? Okay, 9.49. Once we finish, we can move on to the next one. Should be 2 decimal places. Anyway, right, put an F there. Right. Next question. Right, any question for example 3? No? Next question, have a read. Now, I want to show these 2 points lies on a circle of radius with center at the origin. So how do I do that? So if it lies on a circle with center at the origin, what does it actually tell you about the length from the origin? It will show that the 2 lengths must be the same, right? Must be the radius. So what we do is, we're going to find OA, O being the origin. OA is the distance, so you go square root 3 minus 0 square plus -4 minus 0 square equal. And you should get the answer 5. Right? Let's find OB as well. So B is 4, 3. A is 3, -4. Right? So to show it lies on a circle is to show it's the same distance from the center, right? Because a circle is a set of points, it's equal distance from the center, right? Any points you choose on a circle is the same distance from the center. That's what circle means. Okay, so let's find OB. What's OB equal to? I think you get the same thing, right? That equals to 5 as well. So what can you conclude? Since OA equal to OB, therefore A and B lies on a circle. So now you know how to check a point lies on a line. Also check how to check a point lies on a circle. To check a point lies on a circle, we just show it's the same distance from the center of the circle. With center at the origin. With center at origin. Yeah, done. Now, what's the radius of that circle? 5, yeah. Okay, good. All right, there's some keywords you have to learn as well. Let's write it down. So, what have we learned so far? So, there's another way to describe this. We can also say A and B are equidistant from the origin, right? So whenever they ask you to show it's equidistant, is to show the 2 lengths are the same. 2 are equidistant from the origin. In addition to that, we can also show that triangle OAB is an isosceles triangle. Why is it isosceles? If you look at this triangle, yes, Chloe. Yeah, the two lengths are the same, right? Because OA equals to OB equal to 5, right? Therefore, triangle OAB or AOB is isosceles. Done. Okay, any question? After this, we'll look at a slightly harder question, where they give you the distance, and you have to figure out an unknown pronumeral, right? Let's go through that. So this one you have to do a bit of algebra, and then we'll look at midpoint, and then gradient. Okay, let's look at distance. Oh, I still haven't printed out the what file right on the board. All right, I'll print that out soon. Have to edit it. I maybe give it to you next lesson. All right, good. So let's look at the next question. If the distance between these 2 points are 5, find the value of k. So what you do is, using the distance formula, something squared plus something squared, you can write 5 equals square root of 3 minus 7 squared plus k minus 5 squared, right? So this tells you that the distance between these 2 points is 5. You're going to work out k. Now, because that's your x, or you can call this x2, it's interchangeable. x2, y2, x1, y1. Does that make sense? So the x2 minus x1, 3 minus 7, k minus 5, y2 minus y1. Okay. All right, now, any suggestion what we should do to solve for k? Yep, expand. Let's work it out. So 3 minus 7 is negative 4. Negative 4 squared. And then you're going to square the negative 4, which is 16. Now, the first thing you should get rid of is not expand, is to try to square both sides. And when you square both sides, what will happen? That will get rid of the square root. So you get 25 equals to 16 plus k minus 5 squared. Yeah. And then someone suggested let's expand this and you get quadratic. Maybe we'll do that. So if we expand this, we're going to get, let me do it here. All right, let me use a magic pen because that may not be the best way, but I just do it anyway. So if you expand, you get 25 equals to 16 plus k squared minus 10k. Oh, it disappeared. All right, let me try to do it again. All right, 25 equal to 16 plus k squared minus 10. It becomes a circle. All right, a bit annoying. I'll just use normal 10. Okay, so we go 25 equal to 16 plus k squared minus 10k plus 25, right? And then if you simplify, the 25 get cancelled, you end up getting k squared minus 10k, and you have to factorize this, and then find k, right? That's going to take long. Let me show you a faster way. Let me show you a very fast way. Now, the fast way is this. We're going to subtract both sides by 16. 9 equal. Now, what can we do after this? After we subtract both sides by 9. What should we do? We can square root. Can you see I don't need to expand? I don't need to factorize. Do that when it's a perfect square form. So plus or minus 3, and then how do you find k now? Plus 5. So k is 5 plus or minus 3. So k should be 8 or 2. Get the idea? So you get a question like this in your textbook. So remember, you do not need to expand. Just need to keep it in perfect square form. Then you can square root. Thank you. All right. That's the distance. Let's move on to midpoint. Midpoint is very easy. All right, all ready? Okay, let's move on to next page. Thank you. Midpoint. Now, midpoint is a very easy formula. Now, unfortunately, for midpoint, it's not on the reference sheet. So you have to remember, need to memorize, not on reference. Okay, so make sure you remember that. Okay, good. All right, so what we're going to do is we're going to see where does the formula come from so you can remember this. So again, we've got 2 points, A and B, right? So what we do is, like before, we have a triangle. You have a triangle like this. And to get the middle, you get the average. So that's your x1, that's your x2, right? That's your y1, y2. So the middle is the average of the two x values. And the middle of the y is y1 plus y2 over 2. So that gives you the middle, okay? The middle between the 2 points. Okay, so if you average the x, average the y, that gives you the middle. That's called the midpoint, which we denote with capital M, midpoint. Alright, so make sure you memorize this, and we're going to do some examples on that. Alright, copy it down. We'll do 5 pages next week, but 1 exercise or 2. Alright, next bit. Alright, find the midpoint of this. So you write midpoint subscript AB. Okay? So that's your x1, y1, x2, y2. So you average the x. So -1 plus 5 on 2. Average the y. And then add them. So you get 2, 3. Any question? Pretty basic. Okay. Okay, once we find the midpoint, we can actually say the following. If I were to draw this, it will look like this. It will look like -1, 4, and the other one's B, 5, 2. And then the middle, which is 2, 3. So 2, 3 is over here, right? 2, 3. That's your middle. So what that tells you that AM equal to MB. So that if you calculate the distance from A to M, will be equal to the distance from M to B. That's what that means, without using the distance formula. Also, M divides AB in the ratio of 1 to 1, right? Because they are the same. The ratio is 1 to 1, right? So sometimes the question say, find M such that it divides AB in the ratio 1 to 1. It means find the midpoint. So you have these questions in the textbook. So you know, whenever a point that divides an interval into ratio 1 to 1, it means M is the midpoint. Okay? Alright. After we do this, we'll do another one that involves the circle again. Let's draw this picture. If -2, -6 is at the center, is the center of the circle, let's find -2, -6, which is this point here. And then we're going to -5, 1 is the other end point. So -5, 1 is go to the end, -5 to the left, 1 up. Right? So that's the end point of a circle. Oh, oops, sorry. Right. Okay, let's do that again. So negative 2, negative 6 is here. You're right. Negative 2, negative 6. Negative 5, negative 5, 1 will be here. So basically, that's the center, and that's the one endpoint of the diameter, right? That's the one endpoint. The question is, if that's the diameter, which is the same, what's the corner of this point? Okay, that's the aim. So to find out what that point is, let's call that point x, comma y. Okay, and we're going to find what x and y is. Now, what can we say about the center? The center must be, if that's the point A, that's the point B, the center must be the midpoint. Agree? So center equal to the midpoint of diameter. Okay? So therefore, we're going to use the midpoint formula to find B. Okay, so what we do is, let's write down the corner of A and the corner of B. And we're going to find the midpoint of AB. So the midpoint of AB is negative 5 plus x, 1 plus y over 2. Right? That's the midpoint. And then what do? It's equal to the center. It's equal to this thing, right? The middle. So you can solve for x and y. How do you solve for x and y? So you go, this thing equal to negative 2. That's my equation. So you write negative 5 plus x over 2 equal to negative 2. And how do I find x? So you go negative 5 plus x equal to negative 4. X equal to 1. And you do the same thing for the other one. So you go 1 plus y over 2 equal to negative 6. 1 plus y is negative 12. Therefore, y equal to negative 13. Which makes sense, isn't it? You get 1 comma negative 13. So you can conclude the second endpoint, the other endpoint, is 1 comma negative 13. Okay? Alright, any question? So just label this x and y. Alright, that's midpoint done. How we going for times? Pretty good. Alright. Alright, good. Can we let's move on now. Okay? All finished? Done? Okay, next one. Gradient. How do we find gradient? Gradient, the symbol for gradient is small m. So notice that capital M is midpoint. If it's a little m, it means gradient. So there's a difference. And the formula for gradient is rise over run. Okay, let's highlight this. Alright, so let's look at a few simple examples. That's a positive gradient because if you do rise over run, you get 2 over 2, which is 1, right? The gradient. And for this one, it's negative 2 over 2 because it's going downward from left to right. So the gradient is negative 1. And the 0 gradient because its rise is 0 over 2, right? Run is 2, rise is 0. So you get, what's 0 over 2? 0. So a horizontal line has a gradient of 0. How about vertical line? You get 2 over 0. What's 2 over 0? Undefined. So when it's a vertical line, it does not have a gradient. Just remember that. So positive gradient, negative gradient, 0 gradient, or undefined gradient. All right? Remember this clearly. This is important. All right, once we do this, we can then look at, this is all explained here. That's positive, negative, 0, no gradient. Okay, now we have a symbol for gradient for m, rise over run, which is the change in y over change in x. And the formula for gradient is this, y2 over y2 minus y1 over x2 minus x1. That's the formula, because the y2 minus y1 is the rise, x2 minus x1 is the run. Okay, so what we do is that on the reference sheet? It is on the reference sheet, okay? On reference sheet, but good to remember. On reference sheet. Okay, all right, so what else have to do here? Okay. All right, let's move on. Okay, so if a straight line makes an angle theta with the x-axis starting from the positive direction, then tan theta is the gradient of the line. This is an important formula which is not on the reference sheet, so make sure you remember. That's not on reference sheet. Memorize. Okay. Now let's see why tan theta is related to the gradient. If that's the theta there, let's use the different color tan theta. And then we do, this is your rise, this is your run. So what's tan theta equal to? Opposite over hypotenuse, opposite over adjacent. And what's opposite? The rise over run. And this is exactly equal to gradient. That's why tan theta is the gradient of the line. Okay, so this is gradient positive, theta is acute, or basically in other words, theta is between 0 and 90. And what happens if gradient is negative? Theta will be obtuse. And when theta is obtuse, it's in the second quadrant, which is 90 and 180. Right? Because tan is positive in the first quadrant, tan is negative in the second quadrant, yes. This is something new, not done in year 10. I think you've done it in year 10. You've done a bit of it. I think you've done it. It's in your Cambridge textbook. All right, let's move on to do 2 pages of examples, then we're done. Yep. All right, excellent. Let's move on. Yep. That's the angle. So when you measure the angle with the line, it's always start from the positive direction of x-axis and you turn anti-clockwise, like you normally do with trigonometry. So you start from the x-axis, keep turning until you touch the line. So this is obtuse, this is acute. And when it's obtuse, the gradient is negative. When the angle is acute, the gradient is positive. All right, done. Move on. Okay, let's find the gradient. So m equal y2, y1, x2, x1. Get it? Using the formula, you get 7 minus 3 over 4 minus 1. And the gradient becomes 4 over 3. So it's pretty easy, isn't it? Now the question is, what's the angle? So to get the angle, you go tan theta equal to m. And what's m? 4 over 3. And to get the angle, you go shift tan. On your calculator, correct to the nearest degree. So we go shift tan 4 divided by 3. That will get 53 degree, correct to the nearest degree. So it's pretty easy, isn't it? Now, what does the picture look like? So, yeah, that's called the angle of inclination. Yeah, angle of inclination. Yeah. All right, so I forgot to mention that word. Okay. Inclination. So let's look at the picture. It looks like this. So if I have these 2 points, 1, 3 here, 4, 7 there, If you join them, the angle it makes with the x-axis is the 53, alright? And the gradient is 4/3. Does that make sense? Okay, can you try the next one? Find the gradient and hence the angle. Right, it's pretty easy. You should have a try. So m equal -1 minus -2 over 2 minus 6. Have a try. So what would that be? 1 over -4. This time's negative. So when you find the angle, you've got to be careful. So when it is negative, what do? You have to find the related angle. Remember from trigonometry. So you can't just go shift tan of this angle. You go related angle is tan inverse 1/4. Use your calculator. Shift tan 1 divided by 4 to the nearest degree, 14 degrees. And then what you need to do to find the actual angle, you go 180 minus the related, which is going to be obtuse. So the angle will be 160. Why is it 180 in the second quadrant? Second quadrant. Remember second quadrant in trigonometry?
The negative
166. 166.4. Okay, why is it 180 minus? Remember, tan is negative in the second quadrant and the fourth quadrant, isn't it? So your related angle is 14 in the second quadrant and this quadrant. So how do you find this angle? 180 minus. Right, man, from trigonometry. So make sure your older topics are still important. So in terms of the picture, it will look like this. So if I draw a diagram, it will look like 6, -2, and 2, -1. Right, 2, -1. And then what you do is you're going to draw a line, right? That's the line. And the angle we got here was 166. Does that make sense? 166 degrees. And the angle you just found called the related angle is the 14 here. Does that make sense?
So why are you
Well, because when we look at a line, it's either acute or obtuse, isn't it? It can't be reflex. Does that make sense? So basically, if I draw the line, so that's that's like 0 degrees, and then if I go vertical, it's 90 degrees. If I turn that way, it's 180 degrees. Yeah, it's always first or second. Yeah, it does not really make sense. So when you draw a line, if you draw any line, if I draw a line like this, yeah. But you got to understand why. See, if it's like this, yeah, because if it's positive, I wouldn't go that way, isn't it? We'll just go that one. And then when it is that one, you just have to go that way, right? Then all the way to the fourth. Does that make sense? Yep. Okay. Now, the next word is called collinear. What's collinear mean? Yep. Okay. What collinear means? Let's look at it as a two-word. Co means common. Linear means line. So what does it mean? It means all the points are on the same line. That's called collinear. Okay? Collinear means they are all lines on the same line. Okay, so let's write it out clearly. So we write collinear means lines on the same line. And if I put these points A, B, and C, now how do I prove it's on the same line? You don't have to find the equation of the line, but instead, just find the gradient. The gradient must be the same, right? If it's on the same line, the gradient must be the same. So we find the gradient of AB first. Find the gradient of AB, you go -5 minus 3 over -2 minus 2. All right, let's move on. So you get -8 over -4, which is 2. And we'll also find the gradient of BC, which is -1 minus -5 over 0 minus -2. What would that be? You get 4 over 2. Find the gradient of AB, find the gradient of BC, and what do you notice? They are equal. You write a conclusion. Therefore, the two gradients are equal. What can you conclude? It means that A and B and C are collinear. There's another question on the next page. Check whether the other 3 points are collinear or not. If the gradients are not equal, they are not collinear. I'll try the next one, see if you know whether they are collinear or not. Collinear. Co means common, linear, line, common line. Try the next one. Yep. Right, try the next question. Is that collinear? Find gradient AB. 2 minus 3 over 1 minus 2, -1 over 3. Find the gradient of BC. 1 minus 2, 3 minus 1. You can do it without a calculator, so quick. Are they the same? Unfortunately not. So write gradient AB not equal to gradient of BC. Conclusion, are not collinear. So it's a very easy way to check whether more than 3 points are collinear. More than 2 points are collinear. Now let me ask you an easier question. If there are 2 points, are they always collinear? They always have to be. There's only one line through it, right? But if there's a 3 point, it may not be collinear. You have to check. But 2 points has to be collinear. Agree? Yeah. They can't be 2 different lines. So if I have 2 points, there's only one line through it. You just get different line. Yeah. Okay, all right. Yeah, okay. All right, let's move on. Next question. Okay, find the gradient of a line with an angle of 135 with the x-axis in the with the positive direction. So what that means is, if that angle is 135, what's the gradient? So you go tan of the angle, tan 135. How will I work this out? You can press the button on the calculator. But what if you want to know how to do it without a calculator? Related. Oh, excellent. How to find the related angle? Yeah, so you can go m equal to tan 135 is equal to tan of the related. But in the second quadrant, it's negative. Tan 45 is -1. Why would you do that? You would do that for another question. But what if they want it in exact form? So if you want it in exact form, you have to do it without a calculator. Yeah, but that's trigonometry. We did that last term. You need to revise this. Very important. Okay, next one. Find the angle in degrees, minutes that a straight line makes with the x-axis in the positive direction if its gradient is 0.5. So gradient is 0.5, we want to find the angle. So what do? Use the formula. Now remember, it is positive, so you just go tan inverse 0.5. Pretty easy. So you go press the button. Yep. You get 27 degrees. to the nearest minute. So press this button here, 26 and 34. 26, 34. I've got 2 more to go, then we're done. And then you just do 3 exercises over today and over the weekend. Alright, let's move on. Find the gradient of this is 3, find the value of A. So let's do the gradient, 4 minus A over 2 minus 3. And that gradient is equal to 3, right? So we have to solve this equation. How do we solve it? Let's simplify it first. So you get 4 minus A over negative 1. So what do? You multiply both sides by negative 1. And you get 4 minus A equal to negative 3, right? The negative get cancelled. And then what do you do next? Subtract both sides by 4. Then you get negative A equal to negative 7. Therefore, A equal positive 7. Yep. So it's like the one before where they tell you the distance, find the missing value. Or they tell you the midpoint, find the missing value. So you get this type of problem. Got one more question, then we're done. Oh. I can't do this yet. But anyway, is that in the textbook? Show that it's a right angle triangle. Anyway, let's move on. Alright, let's look at this. If A, B, and O is the origin, show that AOB is a right angle triangle. So to show it's a right angle triangle, you plot the points 5, 2, 5 across 2, and then B is 3, 7. That helps you. But where's the right angle? It could be anywhere. So possibly here. Possibly here. So what you do is, to show it's a right angle triangle, method 1 is to use Pythagoras theorem, right? So what you do is find the length of OA, which is 5 squared plus 2 squared, 25 plus 4, root 29. Find the length of OB, which is 3 squared plus 7 squared, 49 plus 9, 58. Okay, so let's label this 3 squared. So that's root 58. That's root 29. Let's find the length of AB. Length of AB is, I leave the working to you. So you go 5 minus 3 square plus 2 minus 7 square. And that will be 4 square plus 5 square. 16 plus 25, 5 minus 3, 2 minus 7, 25 plus, yeah, so you got root 29 as well. Now, does that make this a right angle triangle? I think it does, because if I go OB, so the longer side could be the hypotenuse, so if you go OA square plus OB square, you get root 29 square plus root 29 square. What do you get? You get 58. And if you do AB square, actually that should be AB. Sorry, AB. And that will be OB. Okay, OB square will be root 58 square, which is 58. Now, can you see that the same? We can conclude that OA square plus AB square equal to OB square. So what would that be? That satisfies the Pythagoras theorem. So therefore, triangle OAB is a right angle right, oh, I have to go click back here, is a right angled triangle. Because it satisfies the Pythagoras theorem, and the right angle is at A. At A. Yeah, it took a full hour. I made it. Alright, let's show you method 2. Method 2. You will be. Okay, let's try. Well, if I show you the easy way, then why would I show you the long way? But if you don't know it is a long, if you don't know there's a long way, how would you appreciate this is a short way? And would you believe me? Alright. Alright, let's look at the short way. Okay, let's look at the method 2. Let's find the gradient of OA. What's the gradient of OA? 2 over 5, right? Let's find the gradient of BA. Gradient of BA is 7 minus 2 over 3 minus 5. What do you get? Negative 5 over 2. And then what happens if you multiply them together? No. Yeah, but what do you get? Minus 1. And hopefully you remember from last year, if the product of gradient is negative 1, what does it tell you? No, it means that they're perpendicular. Remember this? So if it's perpendicular, you get 90. So that would be a faster way. Yeah, we'll prove that perpendicular. Thank you. All right, well done. So we start the exercise.